Dina, hurry. We have to call up soon.
Okay, I'm duplicating as fast as I can.
Ah, there's the music. Quick, call up.
Call it time. Way to do my business right. Anaphase One is almost done. Monthly start of Prophase One. Now, your partners do the down. Do see the crossover now. Help me live with your left hand. Promenade around the land. Bracket partners, chromatin, crossing object legend is new and memory breaks the near. Attention, body, central me. Father's code X is done. Hold on down, it's Anaphase One. Couples go to central plate. Anaphase One, so we separate. We get back to reach your goal. Partner move to the other pole. Anaphase One is mighty side. Rolling low, that's what you hate. You can't build a lot of these. I'll tell you what it is to me. Prophase two. Spindles coming after you. With father stuck decentrally, pulled into the center here. Central plate from every two. Slide the forest, deja vu. Anaphase One, you duplicate, that now you can separate. Father stood, this is it. Time to grow that digital slate. Anaphase two, sign your way back to you. Anaphase two, have teams on that. Feeling sad, you're singing straight. This is just your normal state. With some love, you procreate. Rest a while and unwind to a nuclear membrane surrounds you. Now meiosis is complete for nuclei from one's a tree. Cytoplasm will divide, organics fall with you inside. And if you zoom out, you will find many more the same kind. If you're wondering what's the use, also you can reproduce.
Good morning and welcome to Breakfast in Biology.
Good morning.
Day number 35, if you can believe it.
Just a little entertainment for our early birds.
So, that's it. That's what you need to know today. You get that?
I like the I'm scarred for life.
Right. Oh, who's here today? Who did we see? Who was first?
Zuli was first. Darius, Eli, Jake, Cohen, Erica, Dom, Alexia, Jocelyn, Radika, Abby, Kirsten, Gladys, Annie, Maya, Emily,
Home base.
Aiden,
Lurker.
Lurker. Jessica's here.
Alexi? That was interesting. Yes, thank you. Somebody paid attention and thought about it, maybe. That was very interesting.
I think that was interesting.
No, not from her. She's too sweet for that. All right, so let's talk about, we want to keep this kind of short. We have one little thing we want you to do today. And some of you have a lot of little things that we wanted you to do other days that you need to make up. So, how do we make sperm and egg? Because, I mean, really what this comes down to is we want any organism needs the ability to reproduce. It's one of the characteristics of life we talked about in the beginning of the year. So how do we take the number of chromosomes that you are carrying and cut those in half and make it so you can reproduce? And ladies, you out there have eggs. You have all the eggs that you're ever going to have. You're carrying them right now. Something to think about. Your future children are sitting down there waiting. Gentlemen.
Actually made or started to be made while you were in utero. P.S.
Right. Gentlemen. And you love them so much, you're only willing to give them up once a month. Gentlemen, you make them all the time, right? You're making millions. So how do we get to that point? How do we do that? And we're going to go through this kind of quick with the hopes that you've been kind of paying attention. So I'm going to pull up on the screen. Boom. And this should look really familiar. In fact, if I just scroll through like this, you should be like, oh, I know what that is. That's mitosis. But there's a difference. And we talked about that yesterday. There's a difference. And what I want to point your attention to is these chromosomes right here. There's actually, well, can anybody tell me how many chromosomes are in that cell? I don't think it's the best picture, but we'll see if you really have been thinking. Down in the chat, how many chromosomes in that cell? We'll wait. Close, but no cigar, Eli. No, not 8. No, not 8. Where are you getting 8?
Because it's really hard to see, but when you're looking like at the blue and the red, remember that that's 2 blue for each thing.
All right, so Jeff and Jocelyn are the first 2 that have said 6. So I'm gonna, yeah. Like if you look at this blue is a chromosome and it's made of 2 sister chromatids. This red is a chromosome. It's made of 2 sister chromatids. This red is a chromosome made of 2 sister chromatids. That blue is a chromosome, 2 sister chromatids. Same thing down here. So there's actually 1, 2, there's 3 red and 3 blue chromosomes. But where this is different than everything we've talked about before is that the homologous chromosomes have paired up. They're side by side. So it's not just the 2 sister chromatids that are side by side. It's the homologous. So if you go back to that karyotype we showed you yesterday that showed you all the different chromosomes, remember there was 2 pairs for each chromosome because you got 1 from your mommy and 1 from your daddy. In the next phase, this is prophase. We know we didn't start with interphase here because we see the nucleus is breaking down and going away and the chromosomes are all wound up, blah, blah, blah. We go to metaphase. Look at them. They're lined up in the middle, just like normal. But there's a difference because the pairs have lined up in the middle, not just the chromosomes. So in my
tetrad, because there's 4.
Yes. In normal mitosis, we would line them up just 1 chromosome at a time. And then we would split the sister chromatids. But look what we've done here in metaphase 1. We have lined them up in homologous pairs in the tetrad. And in Anaphase 1, we are splitting the pairs. Now, the question for you, did the red chromosomes come from mom or did the blue chromosomes come from mom? What do you think? Red chromosomes from mom or blue? Down in the chat. In the comments. In the live stream chat. Did the red come from the mom or did the blue come from the mom? What do you think? Wait time. All right, I see 2 votes for blue so far.
Interesting.
I see a lot of blutes. Those are blue votes. Blutes.
Blue, huh?
Blue. So how? Everybody says blue.
Did one person say blue and everybody's saying blue?
Jeff jumped on the bandwagon and threw it out there. Everybody's like, Jeff is cool. Jeffy. Jeffy. And so, there's a red. Somebody going against the grain. Let me ask you this. What mechanism, all right, you ready for this? This is a tough question. What mechanism in the cell, what organelle in the cell did we study that would be able to think, mark the chromosomes that came from your mother or your father as coming from your mother or father, and then sort them based on whether they came from your mama or your papa? What organelle in the cell did we study that would be able to think and sort and organize those? The mitochondria. Well, the mitochondria is very powerful. See what I did there, Mrs. Smith? Mitochondria is very powerful. But it doesn't think and sort. We're making a point here. Has anybody figured out the point yet? Well, the ribosome. That's a nice guess. Because the ribosome is just a piece of RNA that helps with making a protein. Would it be able to think and sort chromosomes? The Golgi apparatus. Yes, a packaging structure. It's like calling the UPS man anytime you have a really serious question. The nucleus disappeared, dude. Look at the picture. There is no nucleus anymore. The nuclear membrane's gone. The DNA's all. The nucleolus is gone. And he said the nucleolus. That was a good one. But remember, the nucleolus's job is to make a ribosome. We're just reviewing all the cell parts right now, Mrs. Smith. Thank you for bearing with us. The nucleolus makes ribosomes, and it is gone. Once the DNA wound up, it's gone because it's not really there. We talked about that in a live stream a long time ago. I drew a picture, and the nucleolus isn't, I mean, it's we see it, but it's not really a thing. It's just pieces of DNA and ribosomes all stuck together. Might be wrong. Centrioles. Oh, the centrioles. Can they think and sort? They grab a hold of the spindle fibers and pull. Like fishermen. The rough ER. Nobody has it yet, Mrs. Smith. Let me ask the question again. Is your cell able to tell which chromosomes came from mom and which came from dad? With this one question, I've made our video last 5 minutes longer today than it was supposed to. That's normally your job, and I went ahead and did it. Can your cell tell which chromosomes came from mom and came from dad? This is a really important point. And the answer is not the cell membrane. Although it does determine what gets in or out. So it does make some decisions, sort of, but it doesn't think about them. Plaque said yes. See, this is good that we asked this, Mrs. Smith, because I think the students really struggle with this. There's nothing in your cell that has sentient thought that is going to say, wow, that one came from mom, and I'm going to put a label. Like it's not like your mother getting out the label machine and labeling all the Christmas boxes or something. There's just nothing there that does it. It's a chromosome. The cell can tell that this chromosome and this chromosome are the same, but it cannot tell that this one came from mom and this one came from dad. And if it could, and it put all moms on one side and put all dads on the other side, then one of these sides should all be red and one of these sides should all be blue. And one of the big tips for you today was they're not. So there's actually a law. It's called the law of independent assortment. We don't need to get deep into it, but you need to understand that once you have 23 pairs of chromosomes in your body doesn't know whether you got that chromosome from mom or whether you got that chromosome from dad. This is why we talked about at the end of the thing yesterday. Why do you look different from your mom? Why do you look different from your dad? Why do people say, well, you look like your mom, but you have your dad's nose? Why do you have different traits from different? Because you are getting this assortment. You got half of your mom's genes, and half of those genes, some of them came from her mom, some came from her dad. But it's a crapshoot. You don't know how many. You don't know how many came from your mom's mom and your mom's dad. They just lined them up and they split them. So we lined them up and we split them right here. Now, there's little blues and little red kind of things, tips. Mrs. Smith's going to talk about that in a minute if I hurry up. So anaphase 1 looks very similar to what you see before. We've split the homologous chromosomes. Telophase, right? But notice the nuclear membrane isn't coming back because we never go back to interphase in meiosis. We go right back to prophase, right back to metaphase 2 now, where we've now lined up the chromosomes, and we're going to split the sister chromatids. And I want you to notice something. In the end, this has a long blue one, this has a long red one, this has a long blue one, this has a long red one, but this long blue one has some red on it, and this long red one has some blue on it. And what is that about? Notice something. None of these 4 cells that are going to end up after cytokinesis and they go into interphase and they become your sperm or egg, none of them are the same. Not one of them is the same. And that's super important. That's because of that law of independent assortment and what Mrs. Smith is about to tell you about. You ready, Mrs. Smith?
So essentially, you'll notice that it almost looks like it's going through mitosis twice. So it's like PMAT and then PMAT with no interphase in between. There's still cytokinesis in there too. So we label them as like the first time it goes through and the second time. That's where the 1 and the 2, and we typically use Roman numerals just because that's traditional. So the very first prophase 1 in meiosis, where they line up in these tetrads, where you have these homologous pairs, what happens is that pieces of adjoining chromosomes of non-sister chromatids, so the ones like from mom and from dad, and cross over each other. It's called crossing over. They cross over each other. And then when they pull apart in metaphase 1, they actually exchange information. So imagine like doing like a square dance, which is why we showed that if you were here early, where you kind of link arms at the elbows. Imagine when you were done with that partner, if you both took your right hand and hooked it up with somebody else, and then when you pull apart, you now have a right hand still, but it's their right hand. And so you'll look on the right side of that picture and you'll see that they are recombined now. So you have one chromatid that's still all pink. That's the original from mom. The copy that was all mom, if we're using pink, mom, blue, and your chromosomes aren't colored, okay, in your body. There's not like we can open it up and say, hey, this is mom, this is for dad. No, that's not how it works. They're all the same. So, but for the sake of using this picture, so this one from mom that was like the copy in the center that crossed over is now some mom and some of dad. It's like you have mom's arm with dad's hand. So it's still a hand. It's just different. And you have down to like your knee, and maybe then it's dad's bottom foot and, calf. And then that information switches with that one from dad's, and then you have the one that is that dad's information. So when you're done, you have 4 different chromatids. Each one of those is different. So you take that crossing over, and then you're randomly lined up in metaphase. So when you separate, you get 4 distinct genetically different cells, which is why when you have siblings, and I'm going to flip way back up here to this picture, when you have siblings, they don't all look exactly the same, because every single time that an egg or a sperm is made, it's different. The area that it crosses over is different. So maybe it switches the hand, maybe it only switches the pinky the next time. Maybe when they line up with all mom on one side and dad on the other, and that's how they split up. So you have that difference. And then at the very, very end, it's like, which sperm is it? Which egg is it? So you're going to have some things that look the same, but no two are going to be exactly alike. And I put a little star at the end. And why did I put the star at the end? So no two are exactly alike. Why the star? Think back to biotech. Twins, and specifically identical twins, because identical twins are from one egg, one sperm, that then the zygote splits. Fraternal twins are two different eggs, two different sperm, so they get different DNA. Okay, so the crossing over gives us variety, gives us diversity within even that mom-dad situation.
Which, if we've been foreshadowing a little bit, right? One of the things that we're hopefully going to be talking about before the end of the year is evolution. Actually, one of the things that we've been talking about all year is evolution. We haven't really said evolution that much, but we have been giving you the principles behind evolution, and this is one of them, right? The ability to be diverse, right? So that not every organism comes out the same. This is how we build in diversity. And diversity, having people be different from each other, having the fruit fly be different from each other, that diversity is what allows evolution to happen. And that's something we'll talk about in the future. We have one little thing that we'd like you to do today. And that looks like this. No, it looks like this. It's pretty simple. We try to keep it really simple. We don't want to spend a lot of time on this. We want you to get it. We want you to see it. We want you to understand it, but we're not the deep dive. All you need to do, double click on the picture like normal. That opens up. I'd like you to put these in order. That should be pretty easy if you can remember PMAT and you can count the two. And like you put these in order. You can come up here, click on line, grab an arrow, and once you put them together, just draw an arrow to wherever you need that arrow to go, right? So hopefully the first one that you will have will be Prophase One, and you'll draw that arrow to Prophase One once you put it together. I'm going to delete that before you make a copy of that. And all right, so that's the one thing we'd like you to do. You will find that document in Moodle.
In a minute.
In a minute, you'll find the document in Moodle in a very short amount of time. But until that happens, turn editing on. Oh, editing is on. Oh, look at this. Look at all this stuff that we've done since we've been back. We both know if we don't do it now, we won't do it. Boom. There it is. All right. So I think that's it, right? Crash Course in Meiosis. We want you to go and look at that. Want you to think about it. And then we'll see you tomorrow. We'll see you tomorrow.
See you tomorrow.
Yeah, I think. Do we have anything else?
No. If you have questions, make sure you ask us to meet with you, And we'll see you tomorrow.
Dominic, I see your Zoom question there. I should do that sometime this week. Let me think about that. I'll try and do one sometime this week after the thing. And then I think that's it, right, Mrs. Smith? I feel like we're forgetting something. Stay away from chickens. They're crazy.
Is that our goodbye today?
No, that's what Darius wrote.
Oh.
All right. So, as always, stay safe. Wash your hands.
And stay away from chickens. They're crazy.
Stay away from chickens.
THEY''RE.
What would a buffalo chicken look like? All right.